limits involving one-sided limits. I'll pick some of the problems that are most students find most complicated. Certainly there are limits, one-sided limits in which you can multiply by the conjugate, divide by the highest power of x, and stuff like that. So basically limits that you could determine algebraically from one side. But somehow these functions are typical ones that people seem to struggle with. And because they don't know how a graph looks, knowing calculus, knowing how the graph looks, your parent functions will make your life much more easier in determining limits and so on and so forth, even derivatives, right? So looking at this says, well, the limit as x approaches negative 5 from the right, this plus means from the right, of 1 over x plus 5. Well, certainly if I plug in negative 5 here, I get 1 over 0. Can't do that, right? So basically, I know that this is a reciprocal function of 1 over x. And I'm going to say, okay, well, I'm going to draw a graph and see if we can figure this thing out. All right. Negative 5, at negative 5, there's going to be a vertical asymptote, and this is definitely not drawn to scale. Because at negative 5, the function equals 0. There's no, you see what I mean? Right? And this is coming back from algebra. Alright, so at negative 5, there's going to be a vertical asymptote. There's no x-intercepts. And if definitely there were x-intercepts, we would put it on there. So there's no x-intercepts, which is determined by the numerator. So I could just plug in some points on either side of the vertical asymptote to see whether my function goes to infinity or negative infinity or positive infinity. Because at vertical asymptotes, the function has no choice but to go up to positive infinity or negative infinity. All right. So I could plug in, this is 5, negative 5, so I could plug in negative 4. So the top will always stay the same. So 1 over negative 4 plus 5. Well, it's going to give me a positive. The 1 is positive. Well, negative plus a bigger number is going to be a plus. Yes? So this tells me that from the right, going to, right, this is going to go up to positive infinity. Let's plug in some numbers over here to the left, right? So this is negative 5. Let's plug in negative 6. 1 over negative 6 plus 5. 1 is always positive. Negative bigger number, right, is going to give me a negative 1 because negative 6 plus 1, so that's negative. And any other number. So coming from the left, it will go down to negative infinity. That's what this tells me. Right? So then now I could just go ahead and answer my question. Right? As x approaches negative 5 from the right, right, it's going to be positive infinity. So certainly knowing how the graph look is very important. Let's look at this one. As x approaches 3 from the right, I'm sorry about that, this should be from the right. All right, and this is your function 1 over x squared. Again, knowing how your function look, make your calculus much more easier in these types of situations. And so we could see that we're going to have a vertical asymptote where x is equal to 3, because if we plug in 3 here, 3 minus 3 is 0. 0 squared is nothing, and so we can't divide by 0. So we're going to have a vertical asymptote at 3, right? So let's see, we don't have any x-intercepts again, and if there were, we would have put it on the graph, because graphs do weird things at x-intercepts and vertical asymptotes. Right, so let's plug in some numbers. So this is 3, so I could plug in 2, which would be over here. Right, so 1 over 2 minus 3 squared. Well, the 1 is always positive, and 2 minus 3 is a negative number, but negative 1 squared is also positive. So coming from the right, it will go up. How about from the left? Well, 1 over, let's plug in an arbitrary number, that's 3, so I can plug in 4. 4 minus 3 is a positive number. 1 is always positive, so it's always positive. So 4 minus 3 is 1. 1 squared is just positive 1. So we could see that coming from both directions, the graph is going up. So therefore, we could go ahead and answer a question that as it approaches limits from the right, the answer goes at positive infinity. Let's look at this one, right? Limit as x approaches 7 from the right of 7 minus x. Alright, so again, this is something similar to the reciprocal function, where we have 1 over x. The only difference now is that we have an x-intercept. And so our x-intercept is actually 9, where x is equal to 9. This is not drawn to scale, but I'm going to say this is 9. And we have an x-intercept here. Because remember, at x-intercepts, the graphs could either touch or turn. Right? So either touch or cross. Sorry about that. All right, so we have 1 there at 9. And then x cannot be 7. So we have vertical asymptote at 7. You see? This is 7. Definitely is not drawn to scale again, guys. So bear with me. All right. So now, let's see. All right. This is 7. So we could plug in 6 to see where the graph looks like over here. You see? So 6 minus 9 is a negative number. 7 minus 6 is a positive number. So coming from here, the graph is actually negative. It's negative divided by positive is a negative. Yes. The graph is actually negative. And over here, well, be careful now. I do not want to plug in a number that is greater than 9, because graphs does weird stuff at 9. And so I could plug in 10. The answer, I guarantee, will be positive, but at here, well, it would be negative, but at here it would be positive. You see what I mean? I'm going to show you what I mean. Well, let's plug in a number. This is 7. Let's plug in 8. It's between, all right? So 8 minus 9 is a negative number. 7 minus 8 is a negative number. So the graph is actually positive. You see? And so it would be negative over here. So if we had plugged in, like, say, for example, 10, we would have gotten a negative number instead. And the answer to the question is, as x approaches 7 from the right, it's actually positive infinity. You see? We would have gotten a negative number, and we could say, okay, the answer is negative infinity, when in fact it's actually positive infinity, so that's incorrect. So you want to plug in between the interval of 7 to 9 where the x-intercept is. And so that's why it's so important to put that x-intercept, not just any number above 7, because once this graph passes 9, no, you have a negative. You know the graph is going to, well, essentially 0. Well, no, not 0, but negative infinity. So be mindful of that. The intervals matter. This x-intercept, very important. This is actually the same question, but just a different, from different side. So x approaches 7 from the left. So looking at the graph again, come from the left, the answer is now negative infinity. All right. Approaches 7 from the left is going negative infinity. How about this one? Limit as x approaches 7 of the same question, right? And this is actually does not exist. Why? Let's look at why. And the reason why I did this for a reason. I want you to show you guys the difference. The limit as x from either side is going to be, right? It's going to be one of those infinities. But if they're asking you the pure limit as x approaches 7, just pure 7, and not from the right or not from the left, it actually does not exist, because you see side limits do not match. You see, one is going up, one is going down. So the graph is not continuous there. And one of the discontinuities is actually a vertical asymptote. So the limit does not exist because side limits do not match.